Yeah. So tonight we can try to understand try to understand temperature conversion, right? So well, let me give you an example. Let's see. Let's say we have something like, all right, so T in degrees Celsius is equal to, let's say something like 10 degrees, right? You want to convert 10 degrees Celsius into degrees Fahrenheit. How would you do something like that? So we want temperature in degrees Fahrenheit. How would you do something like that?
9/5 times the temperature of this degree Celsius plus 32.
So to find the temperature in degrees Fahrenheit, it's going to be equal to the temperature in degrees Celsius times 9/5, you say. So you times it by a fraction here, and then you need to increment it by a constant which we say is plus 32.
Question.
Yeah.
Might be a little out to the way, but where did 9 come from?
Which 9?
The 9/5.
Oh, this would come from understanding the scales, the temperature scales then.
Oh.
All right. Yeah. So anyways, so this is the formula you would use to convert at, bear in mind, this is not a temperature change. This is just a temperature. So let's say maybe you have, I know, a cold glass of water, right? And we agree that this thing would have a temperature, right? Like temperature is one intrinsic property of material as well, right?
Yes,
Which would
sir.
be a result of the internal heat within that system. So we agree that this thing would have a temperature at the moment. Because if you take a glass of water to the fridge, right? Well, if you take some water to the fridge and put it on in a cup or something, of course this liquid would have a temperature. Is that so? And we
Yes,
could
sir.
express that temperature in any unit, right? We could express it in degrees Celsius, degrees Fahrenheit, Kelvin. And let's just say that the water currently is at 10 degrees Celsius, but we want to know what the magnitude of that would be in degrees Fahrenheit. So we know we could plug it in this little formula here and basically see the magnitude. So what would we get when we convert this 10 degrees Celsius to degrees Fahrenheit? Plug it in this formula and you would get that value.
So 50 degrees Fahrenheit.
So this would be 10 times 9/5 plus 32, right? And that'd be what? 90/5 plus 32, right? And what was the magnitude there? When you solve that, what would you get?
50 degrees Fahrenheit.
50 degrees Fahrenheit.
50 degrees Fahrenheit. 50 degrees Fahrenheit. Good. Now, look at the question like this now. Bear in mind, this is what? This is you could say a single temperature because there was no change. This was like instantaneous temperature. At this moment, the temperature of this glass of water was 10 degrees Celsius. We want to see what the same temperature is in degrees Fahrenheit. Now, if right, logically, if you take some water out of the fridge, it's very cool, right? It's above 0 degrees. It's not ice, it's water, right? And then you put it in a cup or glass or whatever you want to put it in, some container that could hold it. Or you could even leave it in the container that it was when you take it out of the fridge. Anyways, so you leave it down. So let's draw a container, right? Let's say you put it in a glass, maybe your favorite cup, right? So let's say you put it in your favorite cup. So it's in the environment now. It's in a new environment. It's no longer in the fridge. So of course, the environment that's in now is going to be somewhat higher in temperature than the environment in the fridge. Can we agree on that? Which environment you think have a higher temperature? The environment in the
So
fridge?
the outside environment.
The outside environment. Okay. So what does that mean? So if the glass of water would have a certain temperature when you took it out of the fridge, right? So let's say it's 10 degree currently, 10 degrees Celsius currently. And now if you leave that glass of water, pretend it's on the table. What do you think would happen? Let's say you leave it for 10 minutes. Let's say 10 minutes, maybe 20 minutes. You leave it for some time. What do you think would happen to it?
The water get more warm.
The water get more warm. Okay. So what does that mean in terms of for the temperature? What does that mean for the temperature?
It's
The
gain
temperature
temperature rise.
increases.
The temperature
Yes.
rises because what? It somewhat gain energy from this new environment that it's in. The environment kind of heat it up. So the environment, the water is trying to reach what's known as thermal equilibrium with the environment. You with me?
Clear.
Good.
Yes,
Yes,
sir.
sir.
Now let's say that you could give me a temperature. What temperature do you want me to put here? What do you think would be a suitable temperature?
15 degree.
15 degrees? Okay. So this temperature would be relative to the environment that it's in, right? It won't go past the temperature of the environment. So maybe you have an AC room, or depends on the place where you're living.
So,
Also the weather
question, sir.
condition. Yeah.
so like if this cup play in the sun, and we show this cold water into this cup, whatever climate, like whatever heat, so they're gonna automatically, not automatically, like with time come up to the same temperature.
Yeah, it eventually reach thermal equilibrium with the environment around it. Yeah.
Okay.
So now what just happened here? You have a what?
Temperature change.
You have a temperature change. Now, let's say, okay, what would be the magnitude of temperature change? Let's say, how do we find temperature change? Let's say temperature change in degrees Celsius. How would we find this temperature change?
Final minus initial.
So it would be the T final in degrees Celsius minus the T initial in degrees Celsius. Is that so?
Yes, sir.
So that would be what? 15 degrees Celsius minus 10 degrees Celsius. So this would be how much?
5.
5 degrees Celsius, right? 5 degrees Celsius. Now, let me ask you a question. Let's say I want the magnitude of this temperature change in degrees Fahrenheit. What would I do now?
Convert the single figure, which is 5 degrees Celsius to Fahrenheit.
Okay, so direct me what to do. So let's say I want the temperature in degrees Fahrenheit. So what would you use? Give me a formula that you would use.
Temp Fahrenheit, the temperature is equal to 9/5.
So so the temperature in degrees Celsius times 9/5, that's what you're saying?
Plus 2.
So
The
is
same
it
formula as before.
so okay, so you're telling me that I should multiply the temperature change or the temperature?
The temperature change,
So you're telling me that I should put
multiply the temperature change by
Okay.
9/5 plus 2.
so okay, so delta T in degrees Celsius times 9/5 plus 2. Right? So work that out for me and let's see what we're gonna get. So this is gonna give us 5 times 9/5. So that's 5 and 5 is gonna go out. We would leave with 9 plus 2, and that would be equal to how much? 41. What you guys got when you work that out?
$77.
How much? How much you got?
Did you hear me just now? I
Yeah,
get 77.
I get 41.
77. So 5 times 9 upon 5 is how much, Quincy? 5 and 5 would go out, right?
Oh, my bad. Sorry.
It must be 9
Yeah.
upon 9 plus
Yeah.
so far.
Sorry,
That's
my
9.
bad.
Now, the thing is that, so let me show you an alternative approach, and we're gonna compare it, and then we're gonna conclude what is the correct approach to find the temperature change in a different unit, right? Well, a different unit of temperature. So essentially, this is what we're saying is the temperature change in degrees Fahrenheit, right? So this is what we're saying. So let's,
Excuse me, sir.
yeah,
Question. Sir, how about if initially you changed it 10 degrees Celsius to
all right,
Fahrenheit
good.
and then change it 15 degrees Celsius to Fahrenheit and then
Good.
subtract both?
So let's see when we do that and subtract it, what's the answer we're gonna get and compare it to this here. So
Can that work?
let's see. So you're saying if I have some initial temperature here, which we said was what, 10 degrees Celsius, right? 10 degrees Celsius. So let's turn this 10 degrees Celsius. So this is what T initial in degrees Celsius, right? This is the T initial in degrees Celsius, which is 10 degrees at T initial in degrees Celsius is equal to 10 degrees Celsius. So what he is saying is that let's convert this here into degrees Fahrenheit. Let's do that. So T initial in degrees Fahrenheit, how would we do this? So you're going to be what? 10 times 9 upon 5. Is that so? Plus 32. With me?
Yes, sir.
Okay. So what
So
would
let's
the
go
answer
back
here?
for one more time, please.
Which part?
This from the same part we converting with this the temperature change to the 10 Celsius. 10 degrees Celsius.
So all we're doing is just applying the same formula here that we established. When you're converting from degrees Celsius to degrees Fahrenheit, you could use this formula here. This formula came from understanding the temperature scales.
Okay, sir.
Okay, so it's the same thing that we did here again, but we're trying to check which approach would be correct. Should we convert when we find the temperature change, or should we do it before? So, anyways, we're gonna make our conclusion when we finish here. So, what would the answer here be?
Fifty
50.
degrees Fahrenheit.
50 degrees Fahrenheit. And then our final temperature, which we had was 15 degrees Celsius, right? So this was our T final in degrees Celsius. So our T final in degrees Fahrenheit should be equal to what? 15 times 9 upon 5 plus 32. Is that so?
Yes, sir.
Good. And what's that equal to?
59 degrees Fahrenheit.
59?
Yes, sir. 59.
Good, yeah. So you're gonna be 3 times 9 plus 32, 59. Okay. 59 degrees Fahrenheit. Now, so this is gonna be our T final in degrees Fahrenheit. Of course, here we have our T initial in degrees Fahrenheit. Now our temperature change would be what? Our temperature change in degrees Fahrenheit would be what? T final in degrees Fahrenheit minus T initial in degrees Fahrenheit. Is that so?
Yes, sir.
So this would be what? 59 minus 50. And it should be what? What should the answer here be?
9.
So there should be 9 degrees Fahrenheit. Now let's compare the two answers. Let's compare the two answers. This one you had 41, and this one you have 9. Which one seem more accurate to you?
Sir, the second method.
Good, the second method. So the thing is that the confusion come from this part here. And start to, right? Now if you just do 5 times 9 upon 5, if you just do 5, which is the temperature change in degrees Celsius, right? The temperature change in degrees Celsius was how much? 5. And you notice if you multiply it by 5 upon 9, this part here. Let's say you didn't plus the 32. So let's say 5 times 5 upon 9. Right? Let's say it didn't plus the 32. What your answer would be? Essentially, you would have 9 degrees Fahrenheit, which is what you have here. So let me show you why you don't plus the 32. So you won't use this approach. You won't use this approach. Because this approach here, this formula only works for when you're converting an instantaneous temperature, right? The temperature of something currently. When it's a temperature change, when you're converting a temperature change, you don't add the 32. And let me show you why, which is essentially what we did here. So you had your T, temperature change, right? Temperature change in degrees Celsius would have been what? T final in degrees Celsius minus T initial in degrees Celsius. Is that so? Hello?
Yes, sir.
And if we wanted to find the temperature change in degrees Fahrenheit, what we need to do is convert this final temperature in degrees Celsius to Fahrenheit, convert the initial temperature in degrees Celsius to Fahrenheit. So what we did is we did T final in degrees Celsius, right, times 9 upon 5 plus 32. You with me? This
Yes, sir.
here, all of this here is the what? In final temperature. Then to my, yeah, you with me? Someone asked
Yes,
something?
sir. I got a question.
Yeah.
I see you got these 3 formulas right out of the top with the temperature change, right?
Mhm.
In the case if we can got change of these formulas, like we got do like subject to the formula and change them up by any chance, or they can just work in this straight where we got it.
So generally, whenever you're working anything mathematically, you're gonna have to manipulate the formula or equation to find the parameter that you're looking for. So not all the time you would have it being in the form that is generally given to you. You won't always have the subject of the formula being degrees in Fahrenheit. So let's say or degrees Celsius. So whatever parameter they want you to find, whatever value they want you to find, you would have to rearrange a formula to find that value. And that goes for anything you need to solve mathematically, right? Not just temperature change, anything, velocity, distance, force, anything you need to solve, and you have an equation that have anything in relation to that quantity, you need to rearrange the formula to find the parameter that you need to find. You with me? So that's generally how math work. With me?
Therefore,
Good. So yeah, crucial part of mathematics is to understand changing the subject of the formula. Right? Anyway, so we're here where we need to convert the initial temperature in degrees Celsius to degrees Fahrenheit. So I'm gonna put this here. This is gonna be T initial in degrees Celsius times 9 upon 5. Right, let me put this in bracket, plus 32. Now, I need to simplify this here. So this becomes what? This becomes, I could distribute all this minus sign in here. So it becomes T final, right? In degrees Celsius times 9 upon 5 plus 32 minus T initial in degrees Celsius times 9 upon 5 So this is what? Minus 32, right? Minus, this become minus 32 out here. 32 and 32 go out. I could group these two. You could group these two. So have T final degrees Celsius 9/5 times 9/5 minus T initial degrees Celsius times 9/5. So I noticed that I have a constant here. So I could factor out this constant. So this becomes T final in degrees Celsius minus T initial in degrees Celsius times 9/5. So essentially, if I need to convert this here, find a temperature change. Let me just put this back down here. Temperature change in degrees Fahrenheit. My temperature change in degrees Fahrenheit is actually equal to temperature change in degrees Celsius times 9/5. Does that make sense? Essentially, it just minus the final and initial and times it by 9/5, and you have the temperature change in degrees Celsius, in degrees Fahrenheit. You with me?
Yeah, sir. Yeah.
Good. So when given an instantaneous temperature, all right? I don't know if you want to call it instantaneous temperature, but when they give you a temperature something currently, or a single temperature, then you're going to use this formula here. If they give you a temperature change, you don't include, as you can see, you don't include the plus 32. Okay, so let me give you an example. Let's say that you have, I don't know, just making up some random example here. Let's say this candle burns at maybe 75 degrees Celsius, right? Just some random thing. And let's say that, so this is example 1. Let's say you have example 2. Let's say you have, I don't know, a bowl of ice cream or something like that. And let's say the temperature change, maybe you took it out from the fridge or something, and it changed from, you just have a temperature change, and we know the magnitude of the temperature change. Let's say it's 5 degrees Celsius. So I want you to convert both of these temperature into degrees Fahrenheit for me. So which formula would you use for number 1? How would you find the temp? How would you convert this here to degrees Fahrenheit?
Sorry, you're going to use the formula with the plus 32 inside.
Okay, so good. The temperature in degrees Fahrenheit to be equal to 75 degrees Celsius times 9/5 plus 32, right? And what would you use for this one here? How would you find the temperature change in degrees Fahrenheit?
So since it's a temperature change or delta T, you're going to use the one without the 32.
So good.
Because the 32 can.
So temperature change in degrees Celsius times 9/5, right? So this would be what? This would be 5 times 9/5. So for here, you would have what? You would have 5 degrees Fahrenheit. And here, what would you have? Sorry, you won't have 5. This would be what? 9? Yeah, because 5 and 5 would go out. They'd have what? 9. Make sense?
Sir,
Yeah.
first one, we did finding for the first one, the degrees of Fahrenheit, the, shit. But it's 5 degrees, right?
Yeah. This is degrees Celsius currently.
Yeah, degrees Celsius.
Mm-hmm.
Why we use this formula with the 9/5 and why with the 75 degrees Celsius with 9/5 plus 32?
So good.
why we gonna
This formula here come from understanding the temperature scale. Maybe next session I could go over the temperature scale back. So and standard temperature scale is where this formula comes from. When you're converting from just degrees Celsius to degrees Fahrenheit. As you could see now, like what we did here just now, where we have delta T, when we find a temperature change in degrees Celsius, we know that when we find a temperature in degrees Celsius, we know it's final temperature minus the initial temperature. And if we need to convert the same exact thing here now into degrees Fahrenheit, is the same exact thing. This here is the same as this, but now in degrees Fahrenheit. So I just convert the final temperature into this, initial temperature into this. And when I solve this out, when I work this out algebraically, I know the final answer that I got was this here. So this is how we derive this formula here. We derive this formula from what we just did. Make sense?
Oh, yes, sir. Answer.
Okay. So again, if you need to do the reverse, just manipulate the formula and change for whatever parameter they want you to find. If you need to convert from degrees Celsius, if you need to convert from degrees Fahrenheit to degrees Celsius, just just rearrange your formula and you could do that. You could find. Is that clear?
Yes, sir.
Yes, sir.